We'll start by saying a quick hello and a welcome to everybody that's joining us today as part of our Data Lab community session. So what we're going to do, just as a bit of a format and a bit of housekeeping today, we're very pleased to be joined by a number of our Academy students. We're also very pleased to be joined by partners across the community, and that also includes our partners within the Smart Manufacturing Data Hub. So we're very pleased to have a very large event happening today with us here at the Data Lab community. So just to set the scene a little bit, so I'm Adam Turner, I'm the Head of External Funding Services here at the Data Lab. I specifically focus and look after all of our innovation activities here at the Data Lab, and that largely includes a lot of our large funded activities. Some of our speakers today that you'll be speaking with are partners of ours that we've been working with for the last couple of years, and it's really a great pleasure to have them here joining us today. So this webinar, the title of which is The Value of Data and AI Skills in Driving Research and Development. It forms part of our series of events that we are running, and this is targeted towards our current students and also recent graduates, as well as also people who are perhaps considering career changes into data and AI. It's actually part of our series of webinars that we've been running with the Data Lab Academy. It's actually our third and final installment as part of that webinar series. And the pathway is going to be looking very much at understanding pathways of exploring research and development within data science and AI. So if you wish to go ahead and collect those other two and to catch those other two webinars that I talked about, you can go ahead and find those on our social channels. We would encourage you to do so. During this session, we'll be covering off how R&D underpins innovation, supports the development of technological advancements, and you'll hear firsthand about how this is at the real heart of underpinning some R&D, data science and AI skills. So I'm really delighted to be joined today by Carla Reséndiz and Samuel Ojuri from Norscot, as I mentioned, one of our partners here at the Data Lab and within our Smart Manufacturing Data Hub project. They'll be going and talking about firsthand about how they've been embracing data as part of the culture at Norscot and how AI is helping to make real radical improvements to what they're doing. We'll also be looking at we'll also be speaking with Saleh, who's our head of data at the Data Lab, and he will be giving us his own insights into how manufacturers are becoming more competitive by embracing things like Industry 4 and how harnessing that power of data through the Smart Manufacturing Data Hub. So we'll give a few real life examples of the things that he has learnt and we've been deploying as well. Now, all three speakers are going to share with you today their career journeys. They'll give a little bit of advice on how to get started in the R&D activity and using that data science, engineering and AI skills that we've talked about. So just as a very quick welcome, I want to bring in Saleh, who's going to come on screen with me just now, and I'll let him load up his presentation, and then I will let him introduce himself a little bit further.
Thank you, Adam. I'll share my screen if you can confirm you have my screen.
We can indeed. Perfect. Thank you.
Okay. Thank you, Adam. So as Adam mentioned today, I will talk about mainly the use of the AI and data science for manufacturing innovation in terms of the research and development. My name is Saleh Seyedzadeh. I'm a principal data scientist and also head of the data team for the Data Lab. I have been leading the data team for the Smart Manufacturing Data Hub. Here I will explore the critical role of AI and data science in manufacturing R&D. And I will highlight real-world industry challenges, innovation solutions, and opportunities for collaboration through knowledge transfer partnership. So let's start with the opportunities in the manufacturing industry, which is evolving faster than before. And now companies are no longer just relying on traditional processes. They just need data and AI to stay competitive. So, but what does that actually means in practice? So AI-driven decision-making is not just about automation. It's about enabling manufacturers to make faster, smarter, and more precise decisions. whether it's improving product quality, optimizing supply chain, or predicting machine failure before they happen. So data science and AI are revolutionizing the way companies operate. Manufacturers who effectively use the data don't just reduce costs, they unlock new opportunities for innovation. It could be designing better products, improving production efficiency, or meeting sustainability goals. And here, data-driven insight will be at the core of the modern R&D. The Smart Manufacturing Data Hub, or SMDH, has been a program to boost this in manufacturing. We work with manufacturers to help them harness data and AI in practical and impactful ways. So through collaboration with industry and researchers, we supported manufacturers in using real-time data models, advanced analytics, and drive innovation and efficiency. So whether you're a manufacturer looking into integrate AI into your operation, or a student exploring how data science can be applied in R&D, there are huge opportunities ahead. So now let's look at take a closer look at how AI is really already transferring manufacturing. As you see in the chart, upper chart, which is coming from a survey from Deltoid, manufacturing generates more data than finance, retail, and communication combined. But what does this mean for AI and data science? It means AI and advanced analytics are no longer optional. They're critical to the future of manufacturing, and this shift is not just about machines and automation, it's also about people and skills. So the rise of AI is creating new job opportunities and increasing demand for data professionals who can interpret and apply insight from this massive amount of data. But beyond improving operations, AI and data science are creating entirely new career opportunities in manufacturing. And we're seeing growing demand for AI engineers, data analysts, automation specialists, the roles that didn't exist in traditional factories just a decade ago. So at SMDH, we've seen how data-driven projects supported by research organizations like the Data Lab have helped manufacturers unlock these opportunities. So now let's take a look at what's SMDH and how it helped manufacturers. So SMDH was designed to support SME manufacturers in the UK by helping them to use the power of their factory data. But without the right tools and expertise, these data often goes underutilized. So SMDH was created to bridge this gap, so helping businesses become more competitive, productive, and data-driven. And we had clear goals to helping manufacturers optimize their processes and reduce waste, introducing SMEs to AI and data-driven decision-making, and also extracting valuable insights from real-world factory operations. So the turning raw information into actionable improvements. This was just not a small initiative. Just in terms of the data team, we had 24 data scientists from 5 key partner organizations, including Ulster University, Energy Systems Catapult, Hartree Center, the Data Lab, and we had a big team of a sensor team from IFM, Cambridge University. So together, we delivered over 200 data projects for 140 manufacturing companies. This is still continuing until end of March 2025. And within this program, we delivered over 300 sensors, and we had a manufacturing data exchange platform developed by Hartree Center software team, built over the AWS, and the collaboration was at the heart of this innovation. So our senior members coming from academic backgrounds played a critical role, not only in solving real manufacturing challenges, but also mentoring graduate data scientists, giving them skills and experience to work with in real industrial data. So we learned some very important things about technology adoption in manufacturing. So we learned that by combining research expertise with real-world challenges, we unlock new AI solutions for manufacturers, and SMDH became a stepping stone for AI and data science graduates helping them to transition into industry. And also we found out that many small manufacturers need structured guidance to fully realize the value of data and AI in their operation. So let's look at some of the R&D examples our team has worked on. And one of the most common issue we found was that manufacturers lacked visibility into how their machines were being used. This resulted in hidden inefficiencies, unexpected downtime, and lost productivity. In SMDH, we implemented machine utilization analytics solution, deploying current sensors and machine learning methods to monitor real-time machine activity and classify machine states like working, idle, off, and understanding how much cost is they're spending on each state. So by integrating this data into live dashboards, manufacturers could optimize machine scheduling, reduce idle time, and improve resource utilization, eventually leading to increased production efficiency. So another major challenge was energy waste, where manufacturers struggle to track how and when energy was being used, leading to unnecessary operational cost. We also worked on the half-hourly energy data coming from the smart meters, and we introduced energy insight solution to identify trends in phantom loads, or let's say wasted loads, peak energy consumption, and potential saving opportunities. We had companies that use dashboard to optimize shift-based energy usage and reduce energy waste. Some companies use that for decide whether investing in solar panels would be cost effective, and some others tracked energy consumption across shifts and identified unexpected energy spikes outside the working hours. So all in all, empowered manufacturers to implement energy saving measures, optimize shift patterns, and also reduce their costs. So health and safety regulations was another issue which is becoming more stricter, and yet many manufacturers had no real-time tracking of air quality in their facilities, and this posed a risk to workers and the compliance. So SMDH deployed an air quality monitoring solution to track CO2 and VOCs and particle matters, and a system to detect high CO2 levels during the shifts and correlating them to certain production activities, and so allowing them to improve their air quality by, for example, adjusting ventilation scheduling. And for many manufacturers, tracking job progress was a manual and time-consuming task, and they lacked real-time visibility into job location and status, so leading to delays and inefficiencies. So we just work with IFM team with their scanners and sensor solution, and we implemented job location tracking system to provide live tracking of jobs across different production stages. We had companies that use the system to track the production process for their 180 product variants, identifying where the bottlenecks were occurring. And we also have another company to transition from a paper-based system to digital system, so allowing real-time tracking of orders and reducing manual updates. So even when companies had valuable data themselves, it was often messy, inconsistent, or scattered across multiple systems. So, but without structured data, decision-making was based on merely gut feeling rather than just insights. We also help these companies to clean, structure, and visualize data, turning this spreadsheet-based operation into interactive dashboards. For example, for one company, we analyze their sales and production data, allowing them to optimize pricing strategies and to optimize their production scheduling. So other SMEs automated data collection processes, reducing human error and inefficiencies. So these projects have clearly demonstrated the value of data analytics and AI in manufacturing. But while these solutions are impactful, they represent just the beginning. These are just some examples of what's possible. The real value of data is unlocked when companies analyze the data deeply and fully implement AI-driven solutions. And that's where research and development plays a crucial role. So the challenge is that most SMEs don't have this resource to build in-house R&D teams. Advanced data analytics and AI requires continuous research, experimentation, and development, something that large corporations can afford, but SMEs can't. So this is a major roadblock, and many companies we worked with through the SMDH had valuable data, but lacked expertise and capacity to turn this into fully optimized AI-driven systems. So even if they saw the benefits of digital transformation, without a dedicated R&D resource, progress slows down or stops altogether. So how can SMEs harness the power of AI or other technologies without a full research and development team? So one highly effective way is through knowledge transfer partnership, or KTPs, which provide a bridge between industry and academia, allowing SMEs to tap into university-led research without the burden of hiring a dedicated research team. So through a KTP, companies work directly with the university or research center to solve a specific challenge using data analytics, AR, or other advanced technologies. So a KTP associate, typically a researcher with PhD or master degrees in a relevant field, is embedded within the company and work full-time on the projects with ongoing support from the academia. So the KTP is a three-way partnership between a company that has a specific challenge they want to solve, a university or research institution that provides expertise, and a KTP associate, as I mentioned. But to ensure to the success of the project, each KTP has a supervisor from the academic institution providing technical guidance, research support, and access to expertise, and an advisor from the company ensuring that the research aligns with business objectives and delivers practical impact. So the project typically runs for 1 to 3 years, allowing businesses to gradually integrate AI and data-driven solutions. So throughout the project, the company receives ongoing support from academic advisors, ensuring the latest research is applied effectively. And one of the key benefits of the KTP is that it's co-funded by Innovate UK and making it accessible for SMEs. And SMEs normally pay about 33% of the total cost. The rest covered by government funding, which supports the KTP associates' salary, academic input, and research costs. So this is a low-risk, high-impact way for SMEs to bring AI and data expertise into their businesses without the overhead of hiring a full research team. So for manufacturers, the research organizations, for example, for the data lab, can help you identify key challenges, apply for funding, and provide professional mentorship by hosting the KTPs as an academic partner. So if you are interested in bringing AI expertise into your business, visit Innovate UK KTP website or contact the data lab for further support. And for students and researchers, KTPs provide a unique career path where you can apply your academic knowledge in industry, gain hands-on experience, and receive professional mentorship. So you can find open KTP associate roles on websites like jobs.ac.uk or KTP website, career board, or we have also the Data Lab community job board that you can see some relevant positions. So, but for some students who are more research focused and looking for to advance their expertise beyond industry roles, pursuing a PhD in AI, data science, or manufacturing innovation could be a great path. So there are many funded PhD opportunities available, and you can find these positions, for example, in findthephd.com, and also the jobs.ac.uk has a dedicated part for the PhDs. So whether through KTP's industry collaboration or doctoral research, there are many ways to contribute to cutting-edge advancement in manufacturing research and development. Okay, thank you all for your time. Now I'm handing over to Carla and Samuel from Norscot, who will share how embracing a data and agriculture can help a traditional construction and manufacturing business develop new products.
Perfect. Thank you, Saleh. And just before we hand over to Carla and Samuel, any of our audience members today that are watching this, if you have any questions for any of the panelists, please do feel free to use the Q&A function and collect those. I know Carla, Samuel, and Saleh will be having a chat very briefly once the presentations are formally over. But we would certainly welcome any audience member questions that we have. So please do fire those into the Q&A, and we will certainly come to those. As I mentioned earlier, I am really delighted today to be joined by our friends and our partners over at Norscot. I'm joined by Carla and Samuel, and I'll let them both introduce themselves in a minute. But just to kind of set the scene, Norscot was one of our recipient partners of some of the Smart Manufacturing Data Hub's Digital Innovation Fund, bit of a mouthful there. And effectively, this was to do some really great R&D activity and building new products and services within the business. And certainly today, I'm looking forward to the guys showing you what they've done as part of their showcase. So I'm going to stop talking. I'm going to hand over to Carla and Samuel. I'll let you both introduce yourselves up front if that's okay. And over to you.
Yes, that's perfect. Thank you so much, Adam, for the introduction here, and Saleh for the presentation. And thank you, everybody, for being here. We're going to present, as Adam mentioned, a brief walkthrough of our SMDH demonstrator, which is called Integrating Multimodal AI for Smart Inventory Management. So we had the pleasure to do this in collaboration with a brilliant team, as you can see here. So from the SMDH, we were able to work with Adam and Saleh, but we also had the opportunity to work with an expert academic team from TISA University, including Dr. Alessandro Di Stefano, Professor Farsad Rahimia, and Dr. Faese Bagheri. So from Norscot, Samuel, our junior AI developer and research associate, he was taking and developing this model. And I am product development manager at Norscot, and I was also having the role as project manager for this specific project. We also work very closely with George Mackenzie, he's our production manager here at Norscot. So we're going to talk a little bit about the company, and as Adam and Saleh mentioned, like a little bit how we've been using R&D to develop products and other capabilities. We're going to take you to our demonstrator, how it started and what we did, how some implemented it in the company, the project plan and the milestones that we reached, some challenges and lessons learned, and the next steps for us. So I'm going to start sharing a little bit about Norscot. You might think about like why is a joinery working with AI? So this goes and aligns with our strategy as a company. So our mission is to provide exceptional quality products and innovative designs at competitive prices, backed by excellent customer service. And our vision is to manufacture sustainable, accessible, and affordable products that enhance people's lives and benefit our community, all while prioritizing our customers through a commitment to teamwork, innovation, and quality. So the company started operating in 1984. So we've been out there like for more than 40 years. In 1988, we started with only timber products, specifically windows and patio doors, but then we expanded our product range and we started manufacturing also PVC windows and doors in 1988. Then our catalog of products and offers increased and our team grew as well. So now we have 2 facilities. You can see here a little bit on the map. We are just based in the far north of Scotland, near John O'Groats. And here is where our factory is in Bauer. And we also have other premises in Inverness. which is about 2 hours, 2 hours and a half away from us. But we are basically covering the north of Scotland, and we started as a family business, but now we are more than 60 employees working here. So just to let you know a little bit more about what we do, we manufacture every year more than 4,000 windows of UPVC, alu wood, and timber. Doors, more than 1,000. Timber frame kits, we have approximately 30 of open and closed panel systems. And over the years, or historically, we have manufactured and delivered more than 1,000 homes across the UK. We also have other products like extensions, conservatories, ancillary buildings, and other services such as architectural design, planning processes, design for manufacturing and assembly and the VR. So Norscot has used R&D to develop services and improve our products and processes. Like we had a KTP to implement the design service based on virtual reality. We had another KTP to develop a range of homes for independent living called Will Be. Of that one, I was the KTP associate. And in the future, we want to improve the designs of our products based on occupancy data, energy use, and building use, for example. So we are having further projects to keep improving what we do using R&D. And the current situation is, and why this specific demonstrator project started, was that we found that we were having issues with our raw materials. And for example, we were having a full length of UPVC. And then for manufacturing a window, we were using a certain amount of that full cut, but there were offcuts that weren't being reused or were basically just piling up, which meant waste. And we realized that our current system, which is in place, wasn't prompting to use these offcuts in our production process. So we had these offcuts labeled and stored, which represented like a lot of not only potential waste, but also in materials, but also in space. And basically this was becoming difficult to manage. We know at this point that close to 70% of the offcuts were being recommended, but not all the times they were being chosen or selected by the personnel who was doing selecting the materials for production. So after this overview, I'm gonna pass the presentation to Samuel. So he's gonna explain to us the project scope and objectives. All to you, Sam.
Thank you very much, Carla. Talking about the project scope and the objectives, we set out to implement an AI system that will automate the manufacturing process at Norscot. The use case that we have, the set of the project is one that exemplifies the use of data science and AI using it to create solutions that address identified business problems from the onset of the project. So I'm going to talk about how we went about implementing these using the available data that we have in the factory and the various considerations we made in terms of optimizing material usage, enhancing design decisions, reducing material wastage, as well as improving the overall efficiency of manufacturing processes as well. At the onset of the project, we set out some initial project objectives, which firstly included how do we automate and implement this smart inventory management system that will drive the efficiency of the manufacturing process, and also how do we reduce material wastage, as mentioned in regards to the, of course, that are created in the fabrication process. And we aim at doing this through a data-driven approach that uses multimodal AI framework to about the multimodal AI framework. The data sources that we looked at for this solution, the data sources that are the textual data and image data as well. Lastly, on the objectives, generating a comprehensive life cycle assessment report that shows the environmental benefits of the solution that was deployed in terms of reducing carbon footprint and enhancing sustainability goals that.
Sorry, Sam, the next one?
Yes. Next, we'll look at the implementation design that has the system architecture that we put in place originally to be able to come up with the solution that was deployed to address the business challenges that right. The component on the right has that aimed at driving from the model, and the various use cases are also listed, such as the pattern recognition use case for optimized storage design, which aimed at deploying a system that is optimized for easy retrieval and storage of the materials in the warehouse using artificial intelligence and data science to develop the solution. Also, we looked at another use case that for the of-port reuse recommendation system that is able to recommend of-port for use a particular batch process in a way that will reduce material usage, as well as creating analytics and dashboards and business intelligence reports, what the process data that we acquired during the project to bringing it to life in the way that stakeholders. Looking at the left component that shows the data, it has the multimodal data set that was used which included material usage data in textual format and then high resolution camera data in form of images. This multimodal data set was fed into the data preprocessing pipeline, process the data in a format that can be used by the AI framework to generate the insights. And it's important to mention that in the real world scenario, it's often challenging or might not be what is expected in terms of the data sources that you have available, for example, in manufacturing scenario, in a manufacturing setting, the data sources could be manufactured in various formats. So I've had to use innovative techniques that's data science algorithms to extract this data. Because it's important to have clean data to be able to achieve. Once we're able to process the data in a clean format, the data was fed to the AI framework, and then we were able to achieve the desired insights. Next, I'll go deeper into the pattern recognition. It's showing the architecture of the solution that was developed. Had multimodal data set that used the tabular data and image data. So data preprocessing pipeline. For the images, we used the extraction technique to extract the features of the image and then combine it with the tabular data before feeding it to deep learning model that was able to extract the latent space in the So, this latent space script was there fed.
Samuel, just to jump in a little bit, would you face the camera a little bit better? Just because I can hear that a few of our audience members are struggling to hear you. So would you just make sure that you're speaking directly into the camera, just so we can make sure that the audio is coming through as clear as possible for the audience, if that's possible?
Yes. Okay. So I'll take it again. So this use case demonstrates the pattern recognition use case that has the tabular data and the image data that was used as input data for the deep learning model. After preprocessing the data, we also extracted the image, the features of the images using a feature extraction technique that has to do with transfer learning. The extracted image features was then combined with the processed tabular data before feeding it to the deep learning. So this created a multimodal data set that was used for the deep learning training, and it was able to generate a latent space representation from that data that was used to training the model. This latent space representation was then passed through a clustering algorithm. The clustering algorithm then enabled us to extract the pattern recognition insights that was used to optimize the storage. Okay, so that's all the technical implementation of that particular use case. So the next use case also has to do with this particular use case has to do with using the large language models and AI agents to create a solution that uses simple natural language or simple English to interact with the processed data that is stored in a database, and then retrieve insights in real time, presenting it back to the users so that the user can sort of that with the data using simple English and get insights in real time. This is the second use case, and move on to the reports that were achieved in the project. Next slide. And this particular data assistant deliverable, one that uses an interface to interact with the preprocessed data in the database and allows the user to retrieve insights in real time using natural language, and be able to get details about the data that has been stored in the preprocessed data. Next, move on to another deliverable that is a recommendation system. What we use recommendation system is a system that helps to recommend offers. So when you give the batch for the batch for the production batch, the system is able to give recommendations automatically, and then you are able to generate a report from the system, which you can pass to the operators, the manufacturing. An example of the recommendation report is on the right and shows the reasoning about how the make the necessary implementations.
Sam, I think that bit, we didn't hear you very clearly in the last bit. Can you, or I don't know if it's only in my end, sorry.
Yeah, I said the system also generates recommendation systems report. You have a system report that you can pass into you can pass to the operator in the shop floor, and then that recommendation report, you can then use that the next batch production in a way that will minimize material wastage, because this system is designed in a way that means offers for reuse instead of being wasted. The offers can then be used in new batch.
Fantastic.
Next, we look at the deliverables that has to do with the analytics and visualizations. Because the data has been processed and now available for being analyzed in real time, we're able to get some dashboards and visualizations that shows real time status, how well the whole business is doing at any particular point in time in terms of trends, hiring, production efficiency, wide period of time, and any customized needed for the business. So these are the ways in which we're able to use artificial intelligence and AI techniques. Next, I'll pass it on to Carla to talk about the project plan and project timeline.
Thank you so much, Sam. Yes, so just to let you know, like this was quite a challenging bits of the project after we were trying to progress over it, because a demonstrator project runs over 6 months. So it was quite challenging. But here in this timeline, we show a little bit of how we broke it down into different sections. And also we allocated 5 different work packages, which included just the development of the model, but it also required like a monthly project management, reviews, register updates, and we were also working to try to report this into research outcomes too. So it was quite challenging, but this is the way or how we made it work. So just to share about the challenges and lessons learned, because we realized that a lot of the things that we faced, we weren't expecting it to happen, but it worked very well to have this multidisciplinary approach and involving stakeholders as well. So the challenges were mainly for the restricted access to historical production data from the legacy system, which included the integration, the format of the data, and some of it, when we had to feed it to the model, it required some manual input. Which we think that in the future it can develop to something like an API that needs to be researched further and also developed further. And also knowing that we need to always be aware of the data privacy risks of third-party enterprise AI services for future implementation, and especially if we want to make this to include forecasting too, as a feature of this specific model. The lessons learned based on our original objectives were that for the automation and implementation of the smart inventory system, we didn't reach that fully, but this project set the baseline for future developments. It also helped us just to reduce material wastage, and here it was super important to include key stakeholders, including end users, to prioritize and choose the use cases, for example. So the full smart inventory management system included a lot of other additional sections, but helping break them down into a list, then prioritize and choose, okay, how are we going to start, and what's going to help us progress further in the future after we advance with this first step. So that really helped to start reducing the material wastage. And also to generate a comprehensive LCA report that was even also more time consuming than we expected initially. So we know, for example, we have an LCA report of all of the carbon footprint of all the offcuts that we are reusing and that we are not reusing. So we realized that this specific component needs to have another perspective, including behavioral change and change management, because it helped us understand, for example, whenever the report was showing how many how much carbon we were reducing if we use that off-cut, for example, into our manufacturing. That wasn't really being prioritized, or that was like, oh yes, but that's not really how we make the decisions. So that's something that we have to start also changing, and including these approaches will help us understand how to ensure these type of decisions are embedded in our day-to-day work in the factory, and specifically this model becoming an everyday tool for our team. And the next steps for us is to continue to develop this AI model, including all other features, for example, that recommend optimal stock levels, further enhancing efficiency and reducing waste. We want to implement the recommendations for additional raw materials. So the next step for us is using the double glaze units as well, but we want to progress it later with timber and aluwood, the other raw materials that we use in the factory. And we also want to partner with academic and other industrial organizations. For example, there's other local manufacturers in this area, so we want to reach out with them with these results to see how can we take this further and make them applicable to a broader context too. So that's our plan for this, and that would be it from our end, and we're also happy to answer any questions.
Perfect, fantastic. So I'll let you stop sharing your screen and come back to us. And then I'm going to invite Saleh to come back on camera with us as well. And just while Saleh's coming back on camera, one of the things that we just wanted to run by you, Carla. So thank you very much for your presentations, all of you. Apologies about a few of the sound issues that we were encountering with Samuel's presentation. Certainly, Samuel's in our Data Lab community, so you'll be able to come on and chat to him about some of the great work that he's been doing. I know he's really keen to find collaborators and to communicate the types of things that he's been doing. Carla, you may not have seen actually in the chat window as well to this conversation, a few of our individuals that are joining us today have come up with a few different ideas or a few different suggestions. So be really great to join up those as well. So definitely we'll take that conversation offline. So, but just for now, Carla, one of the things that I wanted to quickly ask you, if that's okay, is so very specifically to some of the activities that are happening at Norscot. Obviously, you guys represent some KTPs and KTP graduates that have come through the program. I think today we've done a really good job of highlighting the types of R&D that is going on within manufacturers, particularly. You know, you guys are really geographically quite far north in Scotland, and it's great to see this happening at a company so pioneering really in this space. I think the ethos of, you know, reducing climate impact and also ultimately reducing wastage and improving the bottom line is significant impacts. Now, from our point of view, this marks a really good thing that Norscot is doing, so culturally bringing in skills into the organization. Are there any best practices that you've found that you, as a kind of technical team, are working with the on-the-ground delivery of products? Is there any kind of best practice that you would recommend that any KTP associates maybe implement, or how do they communicate well with others in the organization to help understand the value of data science and AI within the business?
Thank you so much, Adam. I think for us, what has helped was, well, a parallel to this project, we are also implementing a voice of the customer platform, a CRM. So as Saleh was mentioning before, we are part of those companies that are moving from paper-based to digital. So that has helped a lot to try to, for other team members to know the relevance on how this helps us make better decisions. So I think it's, in our case, it started, for example, initially we had a presentation every quarter, and then it all of a sudden became every month. And sometimes, for example, depending on the team that we are sharing this, sometimes, for example, now the sales team asks us for these data insights every week. So I think it's very important to when we see that if we make our decisions based on data, people start finding the value of it, and I never expected to have that type of collaboration as well with other teams, for example, in this case with sales, in this case for this specific project with production. And I think that is one of the main, I would recommend just show how the information, show the insights, and show what's possible, and then you can take it from there, and more people are gonna hopefully join to that effort.
Fantastic, yeah, and I think just demonstrating that the full integration into the team. Data science and AI is not just the resolve of a small department over here that does really clever things. Actually, it's really showcasing in your instance where it's very much embedded within business practices. And I've seen some of the great pioneering work that you and Samuel have been doing in this space alongside collaborators at Teesside University as well. So fantastic effort in this space. Saleh, I just wanted to perhaps come to you quite quickly. So with regards to some of the resources potentially, as an individual is looking at doing this upskilling and transferring their knowledge out of academic principles and applying them to industry, have you got any kind of best practice or any help guides or guidance as to where people should go and look for some of these resources that you've found helpful on the way?
Yeah, Adam, thank you. Actually, through the SMDH and the academy in the SMDH, we have tried to, because we have an academy, and we have tried to prepare some courses which really fills the gap between, the industry and the academic work. That in academia, the type of the data we are using is just much organized and structured, but when we go to industry, so we face some difficulties because it's not really well defined. It's distributed in different systems, and this really needs understanding of the business itself. So one of the good ways of the data scientists to really go do good practices in their work is to really understand the business and the nature of the business and the systems that the data coming from. And but for the students, there are good resources like some open source data is coming from real world, for example, examples like Kaggle, that the data is not really just a synthetic, but they provide real world data. And also there are some challenges there, and for these challenges there are some also people which tackle the challenges and uploaded their solutions that others can really learn. And of course, another good way is just using the resources like the Data Lab community, where you can have access to mentors which has the academic background and and also industry background, kind of helping them to understand what it really needs, and starting working with industrial data.
That's fantastic, and I think certainly, Carla, I know Samuel, you encountered this challenge particularly around data access with regards to your project, right? And around the length of time that data had been collected. So I think what Saleh was just saying there really rings true to some of your presentation as well, which is very helpful. And certainly our partners at the Smart Manufacturing Data Hub as well, they have a data platform, and on there are some data files in there that actually companies and organizations may find useful, and it's very useful for researchers to go ahead and hone those skills. I think also, Saleh, just reading between the lines of what you were saying there, is that I think practice makes perfect, I think, on some of these areas, right? So I think what you're saying is practice and hone those skills as best you can before you start trying to apply them in industry. Not everything is always perfect, right? So these are what we find particularly across those companies we've been working with. Just very finally, we're going to wrap up in just a very quick minute. I'll open the floor to any questions that any of our audience members may have. So let me just have a quick look here. So what suggestions would the speakers suggest for smaller businesses with limited knowledge of computer systems and how to collect data? So this is almost a kind of way to get started, I think. I'll go ahead and probably answer that question actually. So we've got a series of really helpful guides on the Data Lab community and also on the Smart Manufacturing Data Hub community, which are great starting points as to where a company should get started with this. Likewise, the Data Lab itself has some great opportunities for education content in this space, which is where companies top down can really get a good understanding of what value can come from data. And as soon as they start to understand the value from that data and AI that could potentially come from the back of that, you're able to make informed decisions about the types of people that you need in your business and how you plan for some of this stuff as well. So I don't know, Carla, or Samuel, if you had any additional pointers as to how you got started or any ideas as to what Norscot are particularly looking at.
Yes, actually, I saw that question about also if you are a smaller business, where do you start? So I wanted to mention, like, I think it's very clear just to start. It can start with an Excel spreadsheet, you know. I think it's just to start gathering up, and then also we have to acknowledge that we cannot do everything ourselves. So I would say if you see and track where are the key issues of your business, then prioritize which is the most important for you, and then I would reach to a university or an organization such as Adams or Saleh to say, like, this is what we think we have to tackle first, and then you can take it from there. At the moment, for example, for us, it was because we started, our portfolio has started improving slightly the last couple of years. So we reached out for help. At the moment, we are working with another project of SMDH that is a digitalization assessment. So they are helping us to know which is of all the things that we know we have to do, where to start first. And basically this process is very I would recommend it a lot. So just reach out to these organizations that can help you gain a better like visual or where to start and which are the tools that you need. Sometimes, for example, I recommend sometimes small businesses can be overwhelmed of all of these options. But for example, when I was at KTP, there were other organizations that were only like 1 or 2 people companies, you know, and they also had KTPs. So that is not completely for bigger businesses, you know, or for businesses that are more structured and that have more time operating. So I would recommend just to reach out, and that's a very good first step.
Definitely. And I think that word that you use there, overwhelmed, is something that we see all the time. There's a lot of information for small businesses. There's a lot of, well, that actually applies to all sizes of businesses, but particularly for small businesses of where they start first. And particularly as you start on this journey of working with them as KTP associates or researchers in these fields, one of the things that you need to be cognizant of is that there are many demands of the organization at any one time. So I think doing exactly as you said, Carla, and being part of that conversation, included within that conversation with leadership around how do we find the kind of top 3 priority areas for us to start applying data science and AI. And I think just some kind of best practice that we've found, and I know Saleh would attest to this as well, is don't try and do everything all at once, because you will just get so bogged down by not actually doing anything. So we've got some very good programmatic content in our skills activity here at the Data Lab. And again, this can sit as part of a conversation between researchers and business leaders. It helps to inform that decision making. That helps you to do things like data audits, understand what data sits within an organization, what data resides outside of an organization, how can we use this data, and then also how do you rank and prioritize these focus areas, and then ultimately how do you bring researchers in on that journey and give direction as to where we should start as part of a business. So you guys are great examples of where this has been applied in practice in real life. And we would encourage everybody as part of this conversation to take some of these lessons away today. we are going to have to wrap up our conversations, unfortunately. I wish we had longer. I could talk all day with you guys. It's always a pleasure. I just wanted to thank everybody today for joining us. We will also follow up with any of the questions that have been asked in the question and answer section today. We'll take this offline into our Data Lab community section. Please feel free to come and find the members of the panels today here, and they will also be very happy to answer any of those questions that you were talking about. I know Samuel also loves talking about the data projects and AI projects that you've been doing specifically, so we would definitely welcome you reaching out to them directly. Thank you very much for joining us. Please do keep an eye on the Data Lab community for further upcoming events. We would always welcome people coming and joining us. They're very much often free to attend and very much topical. We've just published our recent themes that are coming up in the community in the upcoming months. So again, we would encourage you to participate in those conversations. For anybody who would like to find out more about various different activities that we've talked about today, we'll make sure that we drop over the link after today's recording with various links included. And anybody that you know that isn't already a member of the Data Lab community that could benefit from these types of activities, please go ahead and shout about it. Go and refer them and tell people to come and join in with the community. We would always welcome them to come and share some of their best practice with our community. And that is it for us today. Thank you very much for joining, everybody, and we look forward to seeing you all again really soon. Thanks very much.